Hey everybody, it's Coach Hammock coming to you from room 122 in beautiful Georgetown, Texas, here at Benold Middle School. Hoping you're having a great day. I'm going to give you some work based on the independent, dependent variable stuff we talked about in class, and then also just introduce a couple of other things talking about different types of correlations, and then how to identify which is the independent and which is the dependent variables. So there's going to be lots of pausing and working out problems on your own. And I'll give you a few seconds head start or notice before I pause or before the answers go up on the board. All right. So first off, you're wondering, what is that picture over there? Well, of course, that's the teddy bear picnic that we talked about in first period at least. I'm making this video during fourth period on Friday, so I haven't talked to any of the other classes about that yet, but we'll see if it comes up. Anyway, here we go. All right, so we're going to determine if each set of ordered pairs represents a function. We're going to write function or not a function. Those are the only answers I want on those, okay? So I'm going to give you a little bit of time. Look at it, compare, go back to your notes, and see if you can figure out 1, 2, 3, and 4 if those are a function or not. All right, so I've done the first two right here. Number 1 is going to be a function. If you look, the x value, which is the independent or the first one in each one, all of them are different, and all of them give you different numbers. So yes, number 1 is a function. Number 2 is not a function, and the reason is this number, this coordinate, and this coordinate right there. See how they both have an x value of 0? That means that they need to give me the same coordinate, the same y value, for it to be a function. And this one does not. This is 0, 4 and 0, 0. So if we were to put those on an xy axis, it wouldn't work. All right, one would be directly under the other. So that is not a function. Look over 3 and 4 and try to figure those out. All right, so hopefully you did well on 3 and 4 right there, and you figured out that 3 is not a function. Again, that coordinate and that coordinate have the same x values, so we would have to have the same y values. With different y values, it's not going to be a function. And this one also, 0, 4, 0, 5, 0, 6, it doesn't work that way. That's not going to be a function either. All right, so let's move on. Determine if the ordered pairs graphed below represent a function. Write a function or not a function. And that's one thing we're really going to have to get good at, is knowing what these points are. So, and just a little tutorial, remember these are positive, comma, positive coordinates. This would be a negative, positive coordinate in this quadrant. Down here, these are negative, negative, and over here, this is going to be positive, negative. So those are our four quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. So if we look at 5, is it a function? Remember, we're looking at vertical lines. We want to know if it's going to hit anything. Well, it hits that one, but there's no point below it. Hits that one, no point below it, no point below it, no point below it. So that is a function right there. Go ahead and do 6 and 7, and we'll check them in just a second. All right, so 6 was not a function because of this right here. When you look straight down, you're going to run into one point there, which means we cannot run into another point for the rest of the time for infinity. But we run into that point right there. So the fact that 2 points are right there on top of each other doesn't work. It's not a function. This is a function, and remember, rain cloud, water coming down, it's going to hit that one and no more. It's going to hit that one and none under it. So they all get wet. It's all a function. All right, moving on. Now for a table. What I'd like for you to do, go ahead and complete this table, and then I'm going to have it completed when you come back and we can check our answers. All right, go ahead. Pause now. Okay, so this is what I came up with for my table. The lists are pretty easy to put in table form. And then if you just take that to go -1, -4, that's how you get your coordinates. Mapping, you don't really need the circles. I just wanted it to look nice, just like the example they gave you. So go ahead and put the circles or not, either way. But it's basically just showing which one corresponds with it. And then the description. And each time that you put in an x value, 0 plus 2 gives you 2. 1 plus 2 gives you 3. 2 plus 2 gives you 4. So most of those or all those should work out right there. All right. Again, if you have a question on something, make sure you write it down on your whisk and bring it to class. Let's move on. Okay. So every day we make decisions based on our effects. Basically, this is saying that you have an independent thing, a value that you can change, and then it produces a dependent thing, a value that is determined by the independent. And this is kind of a hard concept for kids to get, but it really does make sense after a while. Okay? So, for example, we know that there is a relationship between the number of hours that Sarah works at SeaWorld in July and the amount of money she will earn on her paycheck. So what depends on what? Does the hours working depend on the money made, or does money depend on hours worked? Well, in that case, the independent variable, the value that Sarah can directly change, is the number of hours she works. Independent, remember, that's your X value. The money that she earns is going to be our dependent, or our Y. And if you think about just a simple quadrant right here, if this is our X value and this is hours, and over here we have money, if she works 0 hours, she gets 0 money. If she works 1 hour, let's say that she gets $10 an hour. She's going to get $10. So by changing the number of hours, it's going to change how much money she gets in the end. All right? So let's look at a few examples of this. The number of dishes that need to be cleaned and the number of people at the party. So what is it that we can control? Well, to me, and this is open for debate on a few of these, they get kind of iffy, and I'm always up for a good class discussion. Not an argument, but a discussion. The number of people, I think, would be the independent number of people. And the dependent would be the number of dishes. Dishes depend on the number of people. Let's look at number 2. The age of a BMW and the value of the car for the first 10 years. So what depends on what? Well, this one it's a little bit more clear. Of course, the value of the car is going to depend on the age of it. So what's our independent? The independent is going to be the age, and the dependent is going to be the value. The next one, the amount of Fredericksburg peaches grown and the price of peaches. Well, what can we control? Well, we can probably control this, the amount of peaches grown, because if it's a low product, if it's a low quantity yield, then the price is going to be high. If a lot of people grow these, then the price is going to be low. So the independent would be the number of peaches grown, and the dependent would be the price. And I would expect price of peaches right there. The amount of food in a well-stocked refrigerator and the number of people who can eat an afternoon snack. What depends on what? Well, I know that if we have a lot of food at my house, my boys and I can eat. If we don't have much, usually they get to it before I do. So I would say that the amount of food is our independent, because we can control that. And over here, what's going to depend on that? The number of people who eat. All right? All right, if you have any questions on that, bring them to class. Let's look at this now. All right, so you take all these points and you can make these scatter plots. Make sure you know what a scatter plot is. It's not connected, it's just points on a graph. And it doesn't matter what you're graphing, just a independent and a dependent variable. And there we're going to look for patterns. That's all we're doing, is we're looking for patterns to the data. Well, this is called a positive correlation, and you can see that it's going up. Doesn't matter if it's that steep or if it's very shallow, it's going up, and that's called a positive correlation. I remember it this way. This is what I want my money to do over the years. That's a very positive trend. So I am making money. That's a good thing. compared to a negative correlation where it's dropping down. So positive, negative. What if they're spread all over and there's no pattern? Well, that's called a no correlation. There's just no pattern to it. You can't make sense of it, and there's not even a line of best fit. For these over here, if we were to draw a line of best fit, you would want as many points on the top as are on the bottom. Something right around there. Okay? And then for a negative correlation, you can see 3 on the top, 3 on the bottom, spaced pretty evenly, and then 1 on the line. So those would be lines of best fit, but we don't even have to do that. We just need to look at that unless it says draw a line of best fit. Okay, what if it's flat, or what if it goes straight up and down? Well, this is where I differ from the notes just a little bit. They're both called undefined correlations. Later on, when we learn how to graph lines, this is going to be a zero slope and this will be an undefined. We'll talk more about that. For right now, let's just go with an undefined correlation for a flat line, either horizontally or vertically. All right, so here's the example. Joe is a fisherman. He weighs each fish he catches and measures its length. He graphs his data in a scatter plot. Now, we have determined that as the lengths of this fish, what? As the lengths increase, their weight generally increase. Makes sense. The longer the fish is, the more it probably weighs. So when you look at this, this is a positive correlation. That would be a positive correlation. Now, and then this is where we talk about the line of best fit. First off, positive, negative, or no correlation. Yeah, it's going to be a negative correlation. And a line of best fit, as many on the top as are on the bottom, something like that. Doesn't have to be perfect, but pretty close. Later on this year, I'll show you how to input these points into your calculator and actually go through and have it draw a line of best fit on your calculator for you. All right, guys, well, that's it for this lesson. Make sure you get your whisk done and bring it to class on Monday. And if you have any questions, write them down. That's what we're here for. You will have your assignment to do in class, and so the only video that, or the only homework that you'll have on Monday night is to watch another video. All right, I hope this is working well for you. Make sure to get your whisk done. We'll talk to you later. Have a great day.